Pre-calculus. Today's learning target is I can solve radical equations. There are 4 steps to doing so. Step 1 is to isolate or get rid of or get the radical by itself on one side of the equation. You may have to transpose to do so, or multiply by a number, or divide. Step 2, raise each side of the equation to the power that is equal to the index number. Step 3, solve the remaining equation for the variable. And step 4, check the answer in the original radical equation to avoid what's called extraneous solutions. So the check has to be done for every single problem. It's not optional, because sometimes you solve these problems and there will be 2 answers, but only one works. Sometimes you'll solve and you'll get 2 answers and none of them work. And so to avoid what's called extraneous solutions, meaning answers that look like they're working but they really don't, you must check it. When there is more than one radical in the equation, you might have a square root on the left side and then one on the right side of the equation. You may need to repeat the process of raising each side of the equation to the power that's equal to the index number. So a lot of times when you have radicals on the left and the right side of the equation, you may have to actually do the problem multiple times. It just creates a longer question. Example 1. Solve and check the square root of x minus 3 plus 3 is equal to x. First thing we got to do is isolate the radical. We see a plus 3. We need to transpose. The left side is going to be the square root of x minus 3 is equal to x minus 3 when you transpose. Once the radical is isolated by itself, the next thing you do is step 2, raise each side of the equation to the power that's equal to the index number. The index number on this question is 2, since it's a square root, so you're going to do the opposite of squaring, which is the opposite of square rooting, which is squaring. So you're going to raise each side of the equation to the second power. On the left side, you're going to end up getting just x minus 3 back. On the right side, you have a binomial squared. So it's usually easier to just write it down 2 times, and you'll have to use the FOIL method. Remember, binomial squared, you have to use FOIL. On the left side, you have x minus 3. On the right side, you have x to the second. You have outside would give you a negative 3x. Inside would give you a negative 3x. And last, negative 3 times negative 3 is positive 9. You can see that this is a quadratic equation, and so because it's quadratic, you want to make sure you put it in standard form, meaning you want all terms on the same side of the equation, you want it to equal 0. Because this x squared is positive right here, I'm going to actually leave it on the right side instead of transposing, because if I transpose, it'll be a negative 1x squared, and if I have to factor, sometimes that's harder when the coefficient is negative. So my advice is, if the quadratic term, the squared term, is positive, leave it where it is. Combine like terms, negative 3 minus 3 does not cancel. It's actually negative 6x. I'm going to bring this x across and make it a negative x. Drop my positive 9 down. And then transpose my negative 3 across and make it positive 3. And then there's nothing left on the left side, so I'm going to put a 0. So 0 is equal to x to the second minus 7x, and then plus 12. So now that we see it in standard form, it's quadratic, we are going to see if this factors. And you did this process in Algebra 2. We're going to try the trinomial method. Factors of x squared are x times x. Factors of 12 are 1, 12, 2 times 6, 3 times 4. You want to choose the pair that's going to give you a 7 in the middle, actually a negative 7. So 3 and 4 will be your best choice. Remember from last year that when the sign of the last term is positive, that means these signs in your answer will be the same. So they're either going to be 2 plus or 2 minus, and how you know is by looking at the negative sign, or looking at the middle sign, I should say, and if it's negative, you write down 2 negatives. And so now we're left with x minus 3 is equal to 0. And the second option is x minus 4 is equal to 0. And just remember from before, because there's 2 factors here, this, whatever this is, times this factor, because they're multiplied together and it says it's equal to 0, that's why we're allowed to do what's called the zero product property. If we had 2 numbers multiplied together and we know their product is 0, that means one of these have to be 0. And so that's why I wrote it the way I did. And then you're just going to solve. And so this is going to be possible answer, x is 3. And over here, possibly x could be 4. And so I have completed that part, and then the last step in the process for these radical equations is you must check it, because there are some problems there where the answers don't work. Okay, so going back to the first slide, you're going to check your answer in the original radical equation. And so I'm going to go back and choose this one. Actually, I said it that way, but the original, what I meant by that is like it has to have a radical in it, so you technically could check it in this before you squared it. So like one of the 2 that I've highlighted is acceptable for the check. Now I think actually the second one looks a little easier, so I'm just going to use it. So you have to copy it down. And then how you check it is you go back to your answers. We think that we got 3 and 4, so we think 3 is an acceptable answer. So every time you see x in this problem, you're going to put 3 in its place. And so right now, it looks like the square root of 0 is equal to 3 minus 3 is 0. And since the square root of 0 is 0, and the left side is equal to the right side, in other words, these numbers are the same, that's telling me that 3 is the correct answer to this problem. Alright, and then we have to check the other one too. Now we have to take the same problem, write it to the side, and again you'll have to show all of these steps. These problems aren't difficult, they're just, sometimes they're lengthy. And so now you go back and you take 4 and you put it in place of x. So it's going to read the square root of 4 minus 3 needs to equal 4 minus 3. And then you'll evaluate the left side. 4 minus 3 is 1. The right side, 4 minus 3 is 1. This one has a square root, but the square root of 1 is 1. And so since 1 is equal to itself, that also works. And so that basically is just showing that this problem, the first one we did, actually the 2 solutions I got were acceptable. They both did work. So 3 and 4 is the answer, or are the answers to this problem. Okay, example 2. Notice that this one is a cube root. Your job is to solve for the variable, of course. To do that, you're going to have to isolate. You've got to get this by itself, this entire quantity. I notice it as actually a negative, so think about like that as a -1 being multiplied by this. So what I'm going to do is, there's different ways. You can move this over, but I'm actually going to take the 3 and transpose it. So I'm going to write this as 7 minus 3 is equal to -1 times the cube root of x plus 11. And then 7 minus 3, of course, is 0. Let me try that again. 7 minus 3 is 4. There we go. And then you're going to copy down the rest. I'm sorry about that. There we go. Alright, I still don't have the cube root isolated. There's a -1 being multiplied by it, so I'm going to have to show division on both sides. So now -4 is equal to the cube root of x plus 11. Alright, at this point you can see the cube root's the only thing behind the equal sign. So again, our goal is to solve for x. We're going to undo the cube root. So you're going to raise both sides of this equation to the power that's equal to the index. And so in this case it's going to be 3. Okay, -4 to the third is -4 times -4 times -4. And that is going to be -64. And the cube root of something cubed is that something back, and so that's going to be this part. It's the radicand. And then notice in this problem, in this example, my equation has a power of 1, as opposed to the last one, it was quadratic. So if it's linear, you would just expect one answer. So I'm going to transpose the 1 across, get -64 minus 1 is equal to x. And so now it's looking like x is equal to a possible -65, but we have to check it to make sure. So I'm going to circle that, and then I'm going to come over here, and I'm going to do a quick check. Now again, kind of repeating things I've already said, you have to check it in a radical equation. So you could use that one, you could use that step, you could use this step, or you could even use this step that I'm highlighting before you raised it to the third power. Usually it is easiest to pick the most simplified one, which would be like your final one that you see with a radical in it. And so that's what I'm going to choose here. Okay, and I'm going to put a -65, which is what I think the answer is. I'm going to put it in x's place. Okay, and so in the check, I'm just trying to see if this stuff right here equals -4. -65 plus 11. -65 plus 11 is going to be a -54. And I just caught my mistake. Yep, I caught my mistake. And right here, let me backtrack. Oh, I didn't write down the 11. You probably noticed that. Alright, so let me try this again. I'll try to make this quick here. So negative 64 minus 11 is negative 75. Alright. Guess better late than never. So the answer, possible answer, could be negative 75. So let me try to check again. Sorry about that. Let me get it fixed here. The check looked weird, so I noticed there was a mistake there. So 4 equals negative 1. I'm using this one, aren't I? I'm going to keep rolling here. I just changed which equation I was using, but that's okay. Negative 75 plus 11 is negative 64. And so now I'm like looking at 4 equals negative 1. And then this part right here, the cube root of negative 64 is what number times itself 3 times is negative 64? And that would be negative 4. And so now the check is showing 4 is equal to 4. So that did work. Negative 75 is the right answer. I got it. Okay, number 3. Okay, on number 3, notice that there's a square root on the left and then also a square root on the right, and there's a plus 1 here, positive 1. So the first rule is to isolate the radical. Well, if I bring this one over, then this side isn't going to be isolated. So in this case, when there's radicals on both sides and an extra number, you can't do step 1. You're just going to have to raise both sides of the equation to the same power as the index. And what's going to happen here is it's going to create an x plus 1 on the left, and then you're going to have to see this side as 2 binomials. And we're going to have to be really careful on the right side because we see 2 binomials, which means we're going to have to FOIL. Okay, so on the left, we copy it down. That's the easy part. And on the right, we're going to do first 1 times 1, 1. Outside is going to be positive 1 radical 2x minus 12. On the inside, it's 1 times the same amount, same radical. And then in last, you're going to multiply this radical times this radical. And notice the radicands are the same. So it's the same thing as saying the square root of this squared. And so in that case, the radicand is going to be left. Okay, so I'm going to say that last statement again. When you have the square root of something times the square root of the same something, the same radicand, it's like the square root of 5 times the square root of 5 is the square root of 25. Well, the answer to that's 5. So it kind of undoes itself and it gives you back the radicand. And so then, I'm going to switch to topping here for a second. Then you're going to get x plus 1 is equal to 1 plus, and then it's 2. There's 2 of these terms. Of 2x minus 12. And then plus 2x minus 12. Okay, so we're going to start putting everything together that we can. We're going to look at it in terms of making sure, okay, let me do this really fast. Notice that this part is the part that's the radical. Want to make sure we don't lose that. And so this is what we're trying to isolate, meaning we need to transpose all these other terms. Okay, so that's where I am currently right now. So minus 1 when I transpose, minus 2x, and a plus 12. And then that's going to be equal to the 2 times the square root of 2x minus 12. Okay? And so on the left, you're going to see some terms cancel, like 1 minus 1 is going to go away. We're going to add or subtract 1x minus 2x, which is negative 1x. End up getting negative 1x plus 12 on the left side of the equation. And then on the right side, you're going to have 2 times the square root of 2x minus 12. Alright, and then from here, what you're going to have to do is, we're still in isolation mode. We've got this times 2, so we're going to have to divide both sides by 2. And you can see already the problem is a lot longer because there's radicals involved, 2 radicals. I'm going to write this as 2 fractions, so this is going to be like negative 1/2 x. And then 12 halves is 6. On the right side, the 2's cancel, and I'm left with the square root of 2x minus 12. Okay, we still have 1 radical left. We got rid of one of them, but we still have 1 left, so we're going to have to square. And so, honestly, in this type of problem, like I said at the beginning of the lesson, the ones that have more than 1 radical, you're just going to have to understand that it's going to be a longer problem and just keep trucking along. It's all algebra, though. Not a whole lot of new. And then you're going to have to write this down twice, FOIL it, and then when you get that done, then you're going to have to transpose this over. So I'm going to kind of pause here, but this is going to be like you're writing it twice, you're doing FOIL, you're transposing, and then after you get all the way down here and you get answers, because there should be 2, I think, because it's power, then you're going to have to end up going back and checking it in the original problem to see if it works. And I will caution you against like this type of problem. You see me, and I'm still not finished with it, but you see how long it is. With these, you also want to make sure that you have to check all of them, but these notoriously are ones that sometimes don't always work, and so sometimes only one answer works. So please make sure that you stick with it and you follow through and you show all your steps, and don't forget to check these. Okay, so we're going to give that a try, and then the test is coming up really soon on radicals, and so on that test, it'll be probably next week. It'll be on adding, subtracting radicals, multiplying radicals, dividing radicals, and then radical equations as well. Okay, so give this a try, and then I'll check back with you.